that matter can exist in the form of elements, compounds, and mixtures. When elements were discovered, a proper classification was required for their easier and better understanding. Many scientists adopted different ways to classify them. They tried to find out some pattern or regularity in the properties of elements. The first among them was Johann Wolfgang Dobereiner, a German scientist who in 1829 found some groups of 3 elements which showed similar properties. These groups were called as Dobereiner triads. Here, if we have a look at triad table, we can see that the atomic mass of the middle element is approximately the mean of the atomic masses of the other 2 elements. As this classification was a primitive step, Dobereiner could identify only some triads from the elements known. Other triads did not obey the rule. Hence, the system of triads was not useful. After the failure of Dobereiner's triads, the next attempt to classify elements was done by British chemist Newlands. By this time, 56 elements were discovered. He arranged all these elements in an increasing order of their atomic masses and found that every 8th element had properties similar to that of the first. He compared this to the octaves found in music, and therefore this classification was known as Newland's octaves. However, this classification had its own share of shortcomings, the main points being that Newland could arrange elements only up to calcium out of the total 56 elements known, after which the elements did not show similar properties. Also later, several new elements which did not feature in Newland's classification were discovered. After the failure of Newland's octaves, Dmitry Ivanovich Mendeleev, a Russian chemist, put forward a periodic table that was called Mendeleev Periodic Table. Mendeleev examined the relationship between the atomic masses of the elements and their physical and chemical properties. He believed that atomic mass of element was the most fundamental property in classifying the elements. He arranged the known elements in the increasing order of their atomic masses and their properties, and thus created the first periodic table containing 63 elements, till then known as Mendeleev's periodic table. Mendeleev's law states that the physical and chemical properties of elements are a periodic function of their atomic masses. In the Mendeleev's periodic table, the horizontal rows in the periodic table are called periods. There are in total 7 periods. The vertical columns in the periodic table are called groups. There are 8 groups, numbered from 1 to 8. Mendeleev kept some blank spaces in this periodic table. The vacant spaces were for elements that were yet to be discovered. He named them Eka boron, Eka aluminium, and Eka silicon, and also predicted their properties, which later were found to be correct. When noble gases were discovered, they were placed in Mendeleev's table without disturbing the position of other elements. The Mendeleev's periodic table, however, had its own demerits. Firstly, no fixed position could be given to hydrogen in the table, as it resembled alkali metals as well as halogens. At certain places, an element of higher atomic mass has been placed before an element of lower mass. For example, cobalt, whose atomic mass is 58.93, is placed before nickel, whose atomic mass is 58.71. Also, some elements placed in the same subgroup had different properties. Example, manganese, Mn, is placed with halogens which totally differ in properties. Due to these irregularities, a need for a new classification thus emerged. In 1913, Henry Moseley, an English physicist, discovered that atomic number is the most fundamental property of an element and not its atomic mass. This discovery changed the whole perspective of elements and their properties. Accordingly, Mendeley's periodic law was modified into modern periodic law, which states that the chemical and physical properties of elements are a periodic function of their atomic number. The periodic table based on modern periodic law is called Modern Periodic Table. Many versions of this periodic table are in use, but the one which is most commonly used is long form of Modern Periodic Table. We shall now learn in detail about the Modern Periodic Table.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitri Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitri was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum, Eka being Sanskrit for one." Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time: scandium, germanium, rhenium. The element he called Eka manganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitri predicted its existence, 30 years after he died. Dmitri died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitri Mendeleev, the architect of the periodic table, will be staring back.